Okay, folks, this is part 2 of these makeup lectures for Module 2. So let's talk a little bit about consciousness and attention, right? Attention is a pretty important concept in psychology. So here's your textbook's definition: focusing mental resources on specific information to become consciously aware of it, right? So it's the analogy I always like is that it's like a flashlight. It's not an overhead light, it's a flashlight, right? So we can't pay attention to too many things at once. So here's an interesting model of attention. It comes from Daniel Kahneman's book, Thinking Fast and Slow. If you like nonfiction science writing, this is a really cool book. So he's talking in here about the relationship between attention and awareness. And he says we have a two-track mind. Each track involves a different level of attention to produce awareness of particular phenomena. So he says there's kind of the low road and the high road. The low mental road is called System 1, and it kind of operates automatically. It's fast, it's easy, doesn't require a lot of our attention. So System 1 races ahead of System 2. And he's saying most of the time we're kind of running on automatic as we go about our day, right? But a side effect of paying less attention is that we're not fully conscious of engaging in the tasks we're engaging in. We won't be as aware of details of experiences. Good example is, if you're a seasoned driver and you're driving on a familiar route, it can kind of happen on autopilot, something they call highway hypnosis, right? So you can pull into your, destination and not really remember how you got there, like the journey there, right? That's because Kahneman says System 1 was in charge. It's automatic, well-known stuff, so you don't have to think too hard about it. The other system is the high road, System 2. So System 2 uses controlled processing, which means you are consciously aware and you're sort of making an effort to kind of grasp the moment, right? So this kicks in whenever we're doing something that's hard or new, like if you've never skated before and you get on the ice, System 2 is in charge there. You're exquisitely aware of every movement of your body, right? So System 2 activity is slow, it's effortful, it requires more attention, more resources, and that additional attention makes us a lot more aware of our experiences and our mental activity. So for example, if you're driving in bad road conditions, right, you're probably not going to get the highway hypnosis. You're going to be exquisitely aware of like every moment of that drive, or many of them anyway, right? Specific cars, other drivers, your white knuckle anxiety, if you've got that, right? So we'll remember all of that when System 2 is in charge. The reason why System 2 isn't in charge most of the time is because it's effortful, right? It's hard to maintain that kind of volitional awareness all the time. Let's talk about multitasking. There's a limit to how many things the mind can be conscious of. I just realized I didn't start my timer. Let me start it. At the same time, right? So you can't hold too many things in your mind at the same time. This is why we're actually very bad at multitasking. This is why it's dangerous to talk on a cell phone while you're driving, for example, right? And we experience these limits to our attention every day. So Simons and Levin did a cool study showing how we can be oblivious to something, like a really big change in our environment. So this is called change blindness. So they did a study where this guy comes up and asks this old gentleman for directions, right? And while the guy is giving directions, these other people kind of walk between them carrying a door. And during that walkthrough, they switch out the people so that it's a different person at the end that the old fellow is talking to. And in this scenario, people often don't notice that the person they've been talking to is now a different person. Right? So that's change blindness. There is a little clip here. If you just look for Simons and Levin, online, you will find the clip. It's pretty cool. So there are big discrepancies, differences between what most of us believe we can pay attention to and what we actually pay attention to, right? As a result, our perceptions of the world are often pretty inaccurate, right? We're missing a lot as we go through our day. Okay, turning now to sleep. because this is an altered state of consciousness, right? So our bodies have an internal clock that regulates the sleep-wake cycle. Our physiological processes are regulated into these patterns known as the circadian rhythm, right? So the circadian rhythm, circadian means like around a day, circadia. So this is sleep-wake cycle. It's also about your body temperature, your hormone levels, when you get hungry, when you have to pee. All of that is on the circadian cycle. So there's multiple brain regions involved in the circadian rhythm and in the sleep-wake cycle. One important one is called the suprachiasmatic nucleus of the hypothalamus. That is a pretty cool name, right? And this little nucleus, which means a little kind of bundle of neurons, it receives light information from your eyeballs, and it signals the endocrine system to ramp up melatonin production when light levels are low, right? So when the sun is setting and it's getting dark out, that information goes to the suprachiasmatic nucleus, and it kind of charges the hormone system to start pumping out melatonin, a hormone that aids in regulation of the circadian rhythm, secreted by a gland called the pineal gland, right? So you start to feel sleepy. Melatonin makes you feel sleepy. There's a lot of variation in how much sleep different people need. Part of it is where you are in your lifespan. Like babies sleep most of the day. Adults spend about 8 hours a night sleeping. Some adults need more. Some adults can get by on less. It's really rare, though, to be able to feel rested with 6 or fewer hours a night. In fact, there's a genetic kind of mutation for people who are able to do that. So how is being awake different from being asleep? It seems like a weird question, right? But let's break it down. When we're asleep, our conscious experience of the outside world is mostly turned off, although we remain aware of our surroundings to some extent. So for example, your brain controls body movements while you're asleep so that you don't fall out of the bed, usually. Little kids fall out of the bed more than adults do because it takes a while for, the brain to be able to kind of control the body while sleeping. So little kids will fall out of the bed, but grown-ups rarely do unless there's something sort of going on with their nervous system. So what's the brain doing when we sleep? According to EEG readings, that's electroencephalogram readings, that's the readings of the electricity coming off your scalp, there are different stages to sleep, right? So if you hook someone up to an EEG, you put all these little sensors on their head and let them go to sleep, you will see that there are different stages to sleep. Right? So we cycle through 4 stages plus a special stage called REM, rapid eye movement, in 90-minute cycles. And yeah, we identify these by brain waves, right? The patterns of the waves change across the different stages. So let's start with stage 1 here. Stage 1, 5 to 10 minutes per cycle, and you're going to cycle through these stages several times in a night. It's a relatively light transitional stage. So, if somebody's in stage 1, you might say, hey, are you sleeping? And they'll be like, no, I was just resting my eyes, right? So they can sort of come out of it. Sometimes we see students lapsing into this, right, in the classroom. So stage 1 is different from awake in that there are these theta waves that show up. There are these big beefy waves here that we don't see in the awake brain. Okay, so that's how we know they're sliding into stage 1. This is the stage where things like hypnagogic hallucinations can happen. So things like there's an alien in the bedroom or stuff like that. They can be visual and or auditory. Myoclonic jerks, where your body has a sudden shudder, right? We don't know why that happens, but we know it's related to being really exhausted. Right? Okay, so that's stage 1, that transitional stage. Stage 2, 10 to 30 minutes per cycle. Now the person is deep enough asleep that if you say, hey, are you sleeping? They might not respond, right? As much as 65% of your night's sleep is spent in stage 2. And stage 2, in a lot of ways, is preparing you for the deeper stages to come. Your body temperature drops, your heart rate slows. And then these interesting things show up on the readout, sleep spindles, which is that little kind of earthquakey reading, and the K complexes, these big kind of dramatic, changes. So we're not sure why this happens, but it happens in stage 2. And there's some evidence that it might help to keep us asleep when there are external disturbances that might threaten your night's sleep, right? So for example, you're asleep, you're in stage 2, somebody slams the door, and instead of waking up, you have a K complex. Somehow this helps to keep us asleep. Then there's stages 3 and 4 that we're going to kind of lump together in Psych 101, although we have a whole sleep and dreaming course right after 101 if you're interested. So this is deep sleep. You see these great big waves, slow brain waves, and these stages are crucial to feeling rested, right? So deep sleep is where a lot of the replenishing and nourishing factors of sleep kind of kick in. This is what's suppressed with alcohol, right? So if somebody's having trouble sleeping and they get up and have a couple of drinks, they might go to sleep more easily, but they're not going to have the same quality of sleep as they would have had without the alcohol. They're going to be missing a lot of the deeper sleep. Bedwetting and sleepwalking are most likely to happen in these deep sleep stages, especially in the first half of the night's sleep. That's where we often see a lot of the unusual behaviors. And then there's REM sleep, 10 to 20 minutes per cycle. So REM, rapid eye movement, you know the person has entered REM when you can see their eyes moving back and forth beneath the closed lids, right? This is where most vivid dreaming happens, along with that eye movement and a bunch of other things that your body does when you're in REM. So your respiration rate goes up, your brain activity is very busy. In fact, the readout looks like you're awake. And that's because in your dream, right, all 5 senses become activated. You're seeing, hearing, touching, tasting, smelling, talking, feeling, acting, right? And so it's a very busy brain state. It's sometimes called paradoxical sleep. A paradox is where there's 2 seemingly conflicting things going on. The paradox here is that you're asleep and your body is very still during REM. In fact, it's kind of paralyzed briefly. And yet your brain is super active. So yeah, most of the body is paralyzed during REM. It's so that you're not going to get up and start acting out your dreams, right? The genitals also become aroused during REM sleep. This may be because of a sexy dream, but it also is just about your body checking itself, make sure everything's working. So we cycle through these stages in a given night about 5 times in about 8 hours of sleep. So look at this pattern, right? These are the stages, 1, 2, 3, 4. So we go down to deep sleep and then we come up, and instead of waking up, we have our first REM and then down again, second REM, down and up, getting shallower and shallower, right? So, you know, our deepest cycles are in the first kind of part of sleep. And then it gets easier and easier for us to be awakened. And the REM cycles, although this graph doesn't show that really well, but the REM cycles get longer and longer as the night goes on. And by the way, most of us wake up a few times during the night. We may or may not remember it in the morning, but you know, the sleep studies show that people do often wake up once or twice. Okay, what about dreams? We've been interested in dreams for as long as we've had dreams, right? So why? Why does our brain do this? Why does our brain make us basically hallucinate, right? Images, fantasies, stories that often don't make a lot of sense, scenes that ignore the laws of physics, like flying. You know, and why does the sleeping mind confuse these fantasies with reality? When you're in the dream, very typically, you know, you're just sort of accepting it as reality. It's only when you wake up that you go, oh, that was weird, right? So dreams are the products of our consciousness. Everybody dreams, even if you don't remember your dreams. You dream several times a night. It's just, you know, unlikely that you'll remember them unless you wake up in the middle of a dream or right after a dream. The average person spends 6 years of their life in the dream state. And yet while we do it, it's still a bit of a mystery. So we can talk about 2 types of dreams. They're the dreams that happen during REM, so we call those REM dreams. And these are the ones that are often like strange and emotionally laden, visual and auditory components, and that uncritical acceptance of like the weirdness of the dream. And then there's non-REM dreams that often feel very normal, like everyday life. Often, if you wake someone up out of stage 2, for example, they might tell you that they were thinking about something, right? Thinking about how they got to do, the housework or whatever. And the brain areas responsible for the REM and the non-REM dreams are different. In non-REM, many brain areas are basically deactivated, but in REM, the brain kind of springs to life, lots of activity in a lot of particular parts around motor, emotion. The contents of REM dreams come from the activation of brain structures that are associated with motivation, reward, emotion, as well as visual areas, right? Because in your dream, you are seeing things, and areas devoted to movement, because in your dream, you're typically moving around. And at the same time, the prefrontal cortex is less active. The part that would otherwise be telling you, this is weird, that violates the laws of physics, right? Rational thinking kind of is quieted during REM sleep. And so the emotion centers and the visual areas can interact and create these fantasies without rational thought or logic. So what do dreams mean? It kind of depends on who you ask. We go back to Freud for the first kind of taste of a theory that tries to incorporate dreams. Freud believed that there are sort of two levels to your dreams. There's what you wake up remembering, and that's the manifest content. But then there's the latent content. There's what the dream is secretly really about, the true hidden meaning. So for Freud, part of therapy was about, having people report their dreams and him trying to figure out what it was secretly really about. What was that hidden meaning? There's actually no support for the idea that dreams represent these hidden conflicts, right? And that objects in dreams have special symbolic meaning, right? That it's like an encoded message from your id to your consciousness. There isn't support for that. It's even hard to come up with a way to test that idea. So what does the research tell us about dream content? Often our dreams are reflecting our daily lives, daily experiences, and some dreams have themes or stories that unfold. And there are some themes that are pretty common. Dreaming about showing up for an exam unprepared, for example, is a pretty common dream, especially for students. There is a model called the activation synthesis theory that is kind of the current favorite, although it's not perfect. So this is 1977 when they proposed this theory, saying that dreams reflect the brain's attempt to make sense of randomly internally generated neural signals during REM. In other words, when you're in REM sleep, there's all kinds of brain activity, right? Electrical kind of swarming across the cortex. And this is your brain's attempt to make sense of all the stuff that's been stimulated by that electrical activity, right? So dreams, according to this view, are the side effect of mental processes produced by random neural firing, right? If you've got electricity kind of randomly stimulating different parts of the brain, they'll stimulate visual things, they'll stimulate emotion things, narratives, memory, right? And then your brain tries to knit it together. So that's the synthesis part. It's not perfect because it doesn't explain why some dreams do seem to be pertinent to our everyday lives and the issues we're dealing with. Right? This view is basically saying it's just random. Okay, a good place to stop, and we'll do the next piece in the next video. See you there.